That you can put on the internet. That I turn off my Wi-Fi on my phone. I'm like,
absolutely the best internet content.
That stuff does work. Okay. What chit chat do we have? Anything that we want to?
Well, I'm stoked that Josh is wearing an Envy jacket today. I am.
Look, I support the team.
I didn't even realize it till I sat down and you guys both went, whoa.
Envy.
And I am gray on gray. Now, you've said before that you're a big fan of Envy. It just feels a little bit like, you've worked elsewhere in your lifetime, Josh.
I like to think I'm friends with everybody or close to it, but I had to give mad props when I left and announced the SILCA thing and left Zip. I mean, I think it was 2 weeks later, 3 weeks later, this came in the mail from Sarah Ling, who was the CEO of Envy at the time. And she just said, because we were great friends when we were competing.
Sure.
But she sent it to me, and she's like, now you're no longer there. You have a sweatshirt. And as you pointed out, Fatty, this is like the most comfortable sweatshirt in the history of sweatshirts.
Oh yeah, I have the exact same hoodie, and I believe given to me by the same person. They gave me a tour of their original Envy building, which was just a really low rent warehouse in Ogden. Have you been to their new place? It is super nice.
No, I was at the old place and then have since been to the new. Yeah, it's quite impressive. Really impressive stuff.
All right. And this is not the only time we're going to hear about Envy, at least briefly, during this episode of the show. So,
cool.
Appropriately dressed.
Okay.
Well,
I did a little bit of obscuring.
Now I'm interested. You've got my interest.
Oh man, Hadi and I each said, "You want to read up on this question before we record?" And you're like, "Nope, coming in hot, coming in fresh and hot."
I don't even know what you're talking about.
Well, good. This will be fun for everyone.
I thought I read the script last night when you sent out a link and said, "Here, look at all this stuff." I'm like, okay.
Well, I send the script and then I write the script.
Then you write more? Nice.
I like to get in some stuff here, essentially just sort of slip it under the curtain.
Oh, man. I don't read it anyway. So
where is this? Okay, I guess I'll react to along with... here it is.
Oh, it's a good question. It is.
Okay, I see the reference in there. Okay, I got it. Okay.
All right. So, I think we ought to go ahead and do a show. What do you guys think?
Let's do a show.
I'm going to go ahead and start recording in Audition now. Hadi, are you recording?
No.
And I don't think you need to do anything, Josh. We're just
you don't need to back
use
it up Audacity or whatever. Okay.
No, I mean if you want,
idea, but...
it doesn't hurt.
All right.
The 3 levels of redundancy is not a bad thing. We got it on Riverside. I'm recording both of you as my second track. I know Hadi's recording both of us is like third thing. It's really there's going to be 9 recordings by the time we finish this. And watch all of them fail.
Yeah.
There we go. Oh, yeah. Okay. I'm recording. Back up.
On the count us down, Hadi?
This one works.
Keep clearing my throat on the internet. It's not nice.
Geez.
I'm sure people are like,
sorry,
what
YouTubers.
The hell? Yeah, sorry about that, YouTube. But I've got Los Angeles in my esophagus, I guess. Los Angeles air. Okay. This, do you want me to count it in?
There.
Nasty.
Okay, this is Ask Josh Anything number 28. Countdown in 5, 4, 3, 2, 1.
Never
talk over my countdown, Fatty. I mean, never. It's just totally
fighting words.
Oh,
okay.
So rude.
While we're on, real quick, you just reminded me. Have you ever heard of the band Soul Coughing?
Yes.
You ever heard of these guys? So they have a song called Los Angeles. That it's brilliant. You have to check it. They're one of my all-time faves.
Okay. Here we go with an open and a mention of our fine sponsors, and we jump right in. I've kind of eliminated some of the theatrics that get us going on this show. So, streamlined. We've been streamlined. Okay.
Streamlined is good.
It's a marginal gain.
That's right.
We've made marginal gains.
We're trying to finish this show, a quarter of a second faster than we used to.
It should not be hard.
That's not nothing.
Over 100 episodes? That's like 25 seconds.
Now you're thinking.
Yeah.
Okay, here we go. This is the Marginal Gains Podcast, a show that makes a big deal about the little things, and then we go on to explain how those little things really can be a big deal. We are presented by SILCA. They have heritage pumps, wax chains, aero socks, 3D printed tools, just to name some of what that company's up to.
A very few of the many things. I'm Eldon, also known as Fatty. Marginal Gains is also supported by Shimano. Shimano is best known for making the finest drivetrains and brakes, but it doesn't stop there. Shimano also has a helmet company, which is not just any helmet company. They are proudly aligned with Laser, because Laser is very focused. Unlike other helmet companies, Laser's line is bike only. Protecting cyclists is Laser's business, and if you go to Virginia Tech safety testing, no company does it better than Laser. That's what I trust my noggin to. It's nothing but Laser helmets. So, if the new year finds you needing a fresh helmet, and let's face it, it does, check out a Laser at lasersport.us.
This is episode 88 of Marginal Gains, and our 28th Ask Josh Anything show. We've got a lot of questions from our listeners, which can only mean one thing, Josh. That is, Fatty and I have questions too, and we're going to barge right in and ask
jump the line as per the usual. Excellent.
Why break tradition?
Right. Well, I've been very happy with my time here at Marginal Gains University, absorbing all this fine knowledge and using it wherever I can. And last year, like a lot of Marginal Gains listeners, I'm a Formula One fan. I mean, I love to see, what's going on there from an engineering aspect, from a competitive aspect. It's a fascinating sport to watch. And last year, I think a lot of our listeners probably noticed that many of the F1 cars were almost dribbling down the track. They were bouncing. It looked just awful, looked dangerous, in fact. In fact, they had a name for this thing. It was called porpoising. The cars were actually porpoising as they were, some of them, not all of them, as they drove mainly on the straights, the flat-out sides of these tracks. And so I started looking into this. I go, what the heck is going on here with this porpoising? Why is this happening? Well, it turns out, first of all, as Formula One loves to do, it changed the rules, right? It changed the rules and told the engineers they had to start making their cars different. And specifically, they changed the aerodynamic package on the cars. So instead of the Formula One cars being pushed down and using the wings to push down and create traction on the cars were changed so that the cars were actually pulled down. And the way they did this is they created a new underbelly to the car. It's kind of these venturis underneath the car, and it created almost suction. So the cars were being pulled down closer to the ground. These venturi tunnels were pulling the cars down to the ground as opposed to primarily pushing the cars down. Now, what happened here? Well, a lot of things, obviously, with aerodynamics. But in the process of pulling the cars down, the suction effect or the pulling down effect would get cut off. The airflow would get cut off as the cars got closer to the ground, right? And in essence, you had this stalling effect happening. And when the air would stall out, of course, the cars no longer had the pull-down force it needed, so the cars would elevate, right? So the suspension takes over and just pushes the car back up. And as the cars rise, well, back comes the airflow, and the car gets pulled back down again. And what would develop was this so-called porpoising effect. And I was looking at this like, well, that's odd and dangerous and weird and geez, it sounds like something that Josh has talked about on the show. Not so much porpoising or these venturi tunnels, but the act of this up-down. It looked like to me, Josh, this was something that you explained to us, and I hope I got this right as your student, as hop bifurcation. Does this porpoising effect seem like that? Like it's hop bifurcation in action?
Ooh. Yeah, so I've had a number of people ask that question, and it's a really good one. I would say yes. It's a little different than the traditional hop bifurcation case in that it's sort of it's sort of induced by an outside effect, right? So, like you said, the under tray of the car is basically like an upside down wing. The closer you run it to the ground, the more downforce you get until you touch, and then the air is stalled, or the airflow is cut off, the wing stalls, and all the downforce is gone. And it's this like highly nonlinear effect, right? Like the downforce just goes up, gone, like all of a sudden. Mm-hmm. And of course that does allow the car to just kind of jump back up on its springs. There's a ton of stuff in play here, but the thing that makes it a little unique is that, you do have this outside thing, the road, basically hitting the car to cut this off. But then once, as we talked about, the hop bifurcation is you're trading one equilibrium that's stable for another equilibrium that's unstable. And then once you set up into this cycle, like you now have this unstable equilibrium. That is the equilibrium. And so, the car basically goes, bounces up, lift comes back, car sucks down again, hits the ground again, lift goes, lift goes away, or suction goes away. And the car essentially stabilizes like that for the whole trip down the straight. And then when they slow down into the next corner, the car naturally raises up as the downforce goes away, and then it behaves completely differently. So definitely a bit unique compared to speed wobble and wingtip vibrations, aeroelastic wingtip vibrations, and some of the stuff we talked about in our episode on bifurcation. But essentially what you're seeing is the same thing, and it's a really fascinating effect. And I think to me this was just a huge screw up in the way the rules were written, but also in the way the teams dealt with it. We had ground effect cars back in the 80s that had this same effect. I mean, it was very known, and the solutions were very known. And then in writing the rules, the FIA chose not to address it. And then the teams, who darn well should have known better, also screwed it up, which is a little bit shocking to me because it's a hard problem, but it's not an impossible problem. But I would say, a lot of it too is that the teams, like, they get greedy, and the solution is to run the car slightly higher or run it on slightly taller bump stops or whatever. But of course, they don't want to do that because they want the downforce.
Right. Well, and there was a reason for trying to deal with airflow differently, in that, the old way of doing it, where the air would pass over the top of the car primarily and push the car down, was creating all this dirty air behind the race cars, and no one wanted to follow closely, right? So it made the racing kind of stagnant and static, and what F1 was trying to do was create closer racing. To do that, they were trying to clean up the air behind the vehicle. And they did that to a certain extent, but they also caused this other problem, this porpoising problem.
Yeah,
the teams kind of created it on themselves too.
Yeah. I mean, again, so there's a famous race car engineer, Paul van Valkenburg, who started writing, probably in the 90s, about the problems that F1 was having and why they were going to get worse. And he was proposing a series that's essentially pure under tray downforce cars, no external wings. And there's a lot of really interesting solutions in what he was proposing that actually, 25 years ago would have gone a long way to solve these problems. He was one of the guys that, was there in the early, days of side skirts and crazy like suction under trays and the chaparrals and, all the crazy stuff that was happening in the 70s, 80s. He has solutions for this that, I remember learning as an engineering student, reading articles from him and a number of others on it. And I think you would create dramatically better racing. For me, the FIA kind of chose the worst of both worlds, right? They allowed for some really crazy kind of edge-pushing under tray, Venturi tunnel, and they put the regulations in the wrong places on the wrong things, but then they still allowed these wings, and the teams would they use the wings for downforce, clearly, but they also intentionally can use the wings to dirty the air to keep cars from being able to overtake in traffic. And they took a little bit of that away, but they didn't take very much of it away. I mean, there's still a lot of that behavior still happens. So, I mean, we've had okay racing dominated by this porpoising thing, but I would say I personally am disappointed in all parties involved.
Yeah, in mid-season, it's so hard to make changes on these cars. We did see some unique things going on. I mean, some people did suspension fixes, stiffer floors. We saw some side pod reinforcements, almost look like turnbuckles on the sides of these things, trying to, hold these things in place so airflow would remain, so they wouldn't get this hop bifurcation situation going on. Josh, one of the things that turned up when I was reading up on this was some references to this being some type of hysteresis in aerodynamics. What is that? Have you ever heard of that?
Yeah, totally. So it's back to like our hysteresis episode. We talk about the wing stalling, right? That the wing, like you can push it so much farther as the airflow breaks off of it to stall it. But then to actually get the flow to reattach, you have to come to, much better, much lower pitch angles. And the similar thing happens here that as the wing or the under tray or whatever you're talking about is going closer to the road, the flow that's existing there continues to accelerate, creating more suction. But as soon as it touches and the flow is choked off and gone, when it lifts up, all that flow has to be reestablished and ideally reestablish its contact with the surface. And so, if you were to plot, ride height to downforce, it basically as downforce or as ride height goes down, downforce goes up and up and up, and then it pretty abruptly kicks over, or drops back, drops in downforce to zero or near zero, and then when it comes back, it doesn't come back on the same line. It comes back on a much slower path because that flow has to reestablish itself. And so, you could imagine, in a mental model where the flow behaved the same while it was being stalled versus when it was recovering from stall. Your ideal ride height would be 2 millimeters off the ground. And then if you touch the ground, as soon as you got back to 2 millimeters, you would have ideal downforce again. But of course, that's not the case because the flow needs time to flow. And one of the things to think about there too is, there's pretty long lengths involved. And so, you choke the flow to the under tray for that split second, and you've disturbed the entire length of the under tray. And now when you reestablish the flow, it doesn't start up. It doesn't start from zero. You've got to establish along that whole length again. And so, you get into all sorts of really interesting issues. I mean, there's also some, I think, really interesting, one of the reasons they struggled to solve this with suspension is that, the cars run the bump stop like we talked about, and that's typically, I think you run them in mountain bike shocks and stuff too, but it's typically like a elastomer or a hard rubber kind of a stop that gives you a much higher spring rate before the shock bottoms out. And one of the challenges with that is without active damping, you don't have enough positional sensitivity in any mechanical damper that you have damping that matches the spring rate. So your spring rate spikes as soon as you touch the bump stop, but there's no way to make the damping rate jump up to match it. And so the moment you're on the bump stop, all of a sudden that suspension is incredibly underdamped relative to its spring rate. And so you can get into some weird, weird things going on there. And I think you've seen, if the cars didn't have the external wings, we probably would have seen some cars take flight, like we've seen in the GTP and the Le Mans series type cars years ago, where you run them low enough. You get greedy with the downforce. They run low enough. You're on the bump stop. You're way under damped. In a lot of cases, the cars can actually end up bouncing on the tire because the whole system is essentially they like to in NASCAR and in Le Mans car they like to over rebound damp them so that they come up more slowly. And then what happens is the car can end up bouncing on the tires, and you get the right harmonics set up, and all of a sudden you get some oscillations that are tire based. The suspension really doesn't know what to do with it, and then you just a degree of pitch in that under tray in the car. I mean, the car's off the ground, and there's if anybody wants to get on YouTube and look, I mean, there are some just chilling videos of those things going airborne. But those are all, really closely related and intertwined things. And again, the way the rules are written for F1, they can only make so many changes to the cars that are so big. And so, they all played with too big and too hot of a fire, and then they couldn't walk it back over the course of the year.
Well, one of the new rules is that the floor height has to be increased by 15 millimeters for the 2023 season. And they talked a lot about diffusers too, Josh, that they're going to have their edges stiffened up. What are the role of diffusers here? And we'll try to connect this to bikes. Have we ever seen diffusers used anywhere on a bicycle?
I don't think so. Not really. I mean, the diffuser is really essentially it's the trailing part of the upside down wing. In the race car. So you've got the under tray and you've got the Venturi tunnels where they're trying to kick up some vortices with these little strakes. And if you see the modern under trays, I mean, some of them look to have what are like a million little carbon fiber strakes that set up these little vortices. And so you get the swirl in these vortex tunnels, and that's creating downforce due to pressure drop. And then as you get to the back of the car, that essentially the tunnel goes up. And so if you think of it like an upside down wing, it's, the middle of the car is like the middle of the wing. And then as you go to the back, it's actually lifting up, and it's giving you additional lift. And then they put strakes in there, and they use that to try to, increase suction. I think that the ideal is you kind of want peak suction to be like a little in front of the rear wheel contact patch, more or less. But then you want to control that air because you want to bring it and kick it up in the back so that it can have interplay with your rear wing. Right. And that'll help in both downforce creation, but also drag reduction. And so the downside, the upside of the diffuser and the ground effect is that it's really, when it's done right, it's super efficient downforce, or as I would normally say, like it's really efficient lift creation. It's just negative lift. We in cycling we just don't need lift. Like a disc wheels and super deep section wheels, you get those sailing effects in crosswind, and that is a lift effect. But that's a lift effect from, having flow attachment across a range of yaw angles. And so, to really have something like a diffuser work, I think you need consistent directional lift or downforce, and we just don't have that. Okay. You've seen some similar things like what's happening in MotoGP. They're trying to use some similar elements, but even they don't, that I've ever seen or know of, they aren't really using diffusers in that sense. So you may see, I would say if it does appear anywhere in MotoGP or motorcycle, people are using diffusers or at least the properties of diffusers, probably in like for cooling purposes. You're trying to create like a suction zone to like pull cooling flow through or something like that. Would be my guess, but I can't say I've ever seen it.
Well, thank you for. I'll wait for my grade a little later on my, my paper that I submitted here. I'm sure you have lots of papers to go over, but I thought I was onto something there. I just wasn't sure, and that's why I have this podcast so I can test my theory.
It's totally. I mean, I have to say, I get totally fascinated by that world for a ton of reasons, but. One of them is this sort of almost freeing element of, downforce is so much more important than drag that when you look at a lot of the stuff that they're doing in those cars, they're like, fuck it, add the drag, right? Right. Yeah. And, they're really intentionally doing draggy stuff to make more downforce. And I think, that's this flying closer and closer to the edge thing that we talk about that, that gets them in trouble. And I think, I think with a slightly different rules package, they probably would be forced into making some subtly different decisions that would not only fix the problem, but I think make the racing better. And I mean, if it were up to me, I'd bring back, I'd allow them to use side skirts, right? Because side skirts sort of like, block the lateral entry of flow from beside the car. But then also with the side skirts, they use essentially like, scraping blocks to like keep the car the fixed distance off the ground. And so it introduces a whole new interesting set of problems, but it also allows you to simplify the wings. And personally, I think the cars they're just fugly right now. I mean, they're just, like, wow, a 27 element front wing, I totally get the point of that, but it just doesn't look good. And the cars, especially now that they're not refueling, to make all this stuff work, they've gotten to be, they're like almost the length of an F-150 pickup. I mean, they're just these giant monstrosities. So from my eye, they're inelegant machines, and I would love to see it go back to, something like maybe the size of like a 2000, year 2000 car with like maybe single or dual element wing limits, and then let them go bonkers with the under tray. That would be because I think the racing would become quite good.
Mm-hmm. I'm kind of hearing an echo of the let's keep the bikes in the hour record held to the Eddie Merckx standard here.
No, I wouldn't go that far. I mean, we could easily say like let's take it back to like, Dan Gurney and the drop tank, shaped cars of the 60s. And I mean, there's a part of me that loves that, right? I mean, you look at that old racing pre-downforce, and I mean, that was beautiful racing. But, we have other series that can bring that in. I mean, it wouldn't be F1 if you didn't have some incredible level of technology development. So I think for me, it's just, the huge size of the cars makes them they're too big for a lot of the circuits, right? And then you start building these modern circuits that can better handle these really big cars, but now you start to really lose your sense of speed of the cars. And, you look at like a lot of the footage and stuff you see of F1, I mean, the really good stuff is generally sped up a little bit, right? Or really highly produced in a way to make it, I mean, the Netflix series has done an amazing job making F1 look really good. But, to see the cars race in person now, to me, that they're just not as impressive. They're not as tight. They don't rotate nearly as quickly. But, things like 4 feet longer than the car of 20 years ago. Like it just, it's physics. Like it can't rotate as quickly because it's fucking huge. No matter what the downforce is. So that, I would change all that. But, at the same time, nobody asked. So.
Well, Hadi asked.
Yeah, I do.
So, my opinion in
$4
will get you a Starbucks.
The Marginal Gains Podcast, a podcast that used to be about bikes. So I have a question that I actually heard. That I guess there is a new way you can submit your questions for the Ask Josh Anything, and one of them is for me to overhear you while I am on a group ride. I was on a mountain bike ride on the world-famous Gooseberry Trail, amazing network in Hurricane, Utah. And
Fatty, hold on. Wait, Fatty, I'm going to stop you right there. It was such a good
setup. I know. It was such a good setup, Fatty.
I was listening to your audio, Fatty. I want you to check your mic real quick.
What's up?
You sound like you're coming through your computer mic.
Oh, that would be bad.
Yeah. Tap your mic. Nope. Yeah, we're not getting that mic.
Oh.
Yeah. That's what I thought. And now it says your mic is off.
It's the sexy part of podcasting for
I know.
For the YouTube audience.
It won't show up on the audio version.
Is that better?
Tap your mic.
Am I back on?
Nope, that mic's not on.
I'm hearing it through my monitor.
Oh. As long as you're recording your...
Are you getting that one?
Which one?
This one, the other mic.
Nope.
No? Well, it is. I'm coming in strong on my local recording, so if you can hear me.
Yeah, I can hear you, and likely the local recording is recording that Shure.
For sure it is.
Yeah.
I can tell that is coming in. Yeah, that's my Scarlett Input 1.
We might be picking up. Is there a built-in mic on the Focusrite? There might be some type of talkback mic on it or something like that.
Okay. I don't think so.
Yeah, we're not getting that Shure at least over Riverside, so that's fine.
Yeah,
I mean, the YouTube will sound like whatever mic that's picking you up. It should be okay though.
Oh yeah. Well, the podcast the audio will be better.
Okay.
I can live with it.
Okay.
Can you live with it?
I can live with it. Yeah.
Okay.
Well, I just do the audio side, so yeah. Okay. Sorry, you were saying.
Okay, I'm going to go back.
Okay, go back.
Or actually, why don't you just go ahead and pick up with your response?
Okay. Fatty, did you say hurricane?
Yeah, hurricane. It's spelled like hurricane, and it's right next to Laverkin.
Great.
No, I'm dead serious. And in Utah, we pronounce things the way that we want. And one of the writers in my group is an actual rocket scientist. He leads a team of engineers who design titanium and carbon fiber parts for rockets. And he used to be a QA engineer for Envy. He is an amazing mechanic, both cars and bikes. And the trifecta is he's also one of the most technically gifted writers I have ever met. Obviously, I have a lot of respect for the guy, so I was listening very closely when he was having a conversation with someone in our group and was asked how he feels about repaired carbon fiber frames. His answer was very short and very clear. He said, with what I know about carbon fiber, I would not ride a mountain bike with a repaired frame. And I was shocked because I wasn't at the moment, but I have ridden with repaired frames before. So my question for you, Josh, who used to work at Zip, who's currently wearing an NV jacket, how do you feel about repaired carbon fiber frames?
Can we say it depends?
Yep.
Is the standard. I totally, for me, depends on, where it was broken, how it was broken, who repaired it, what they repair it with. Certainly not all damaged frames are repairable. And, I think there are folks out there who are doing this really well. We had Sean from Ruckus Composites on here. He's a friend of mine, brilliant guy, really doing amazing stuff with carbon fiber repair, and is also the first guy to tell you, if you send him a broken frame, that this shouldn't be repaired. And I think that's the key. Just because it can be done doesn't mean that it should be done. And so I would say, those sorts of things fall into really two distinct categories. Like this is doable safely. And, in most of those cases, you're going to add some weight and some complexity back to the frame. I think ideally you're not going to spend more than the frame cost to repair it because, as anybody knows, it's like working on your old house as the owner of a 100-year-old house, right? Everything costs twice as much because you have to undo all the stuff to begin with and then redo it to fix it. That's totally true here. So, but I know for a fact that I've seen it tested that, repaired carbon can be as strong or stronger than it was from the factory. So it's totally possible, but at the same time, absolute case-by-case basis as to what the problem is. And then, if you're going to attempt it at all, it should be done by professionals who do carbon repair. Here in Indy, we actually have the very beginning of Zip, we were still doing a ton of race car parts, and so we did wings and seats and steering wheels, and we did a ton of chassis repair. And so you think the $500,000 carbon tub for an Indy car, you crash it or get a hole in it, you don't replace it, you repair it. it's a very, very special skill. And so, I have good friends and former employees who still work in that business and do it at an incredibly high level on both aircraft and race cars. So I would say, you have certainly flown on a plane that has some repaired carbon part in it of some fashion. So, I mean, it can and does work. And, I think we are also getting to a place where a lot of things are being more designed for repairability. And I cannot say that about bicycles or the bike industry, right? I mean, we're really continuing to design bicycles for disposability. And so that, I think, makes the required technical skill of the repair technician even higher. And that's what I love about Sean. I mean, he works with, he's an expert in non-destructive testing and ultrasound and, kind of all of these other techniques that can really guarantee that what you have to repair before you even start, and then being able to go back and scan it and study it to know that you've done it right once it's done. I think all those things have to be in play for it to be safe.
How about wheels?
I would never repair a wheel. I don't know of anybody who would. Yeah, I think it's the complexity is too high, the risk is too high, and I would say the other piece of that is even if you can, so many of the wheels today are designed with intentional compliance, which is actually one of our patents from Zip that's off and people are doing it. The thing that you're never going to get away from with a carbon repairs, you typically do these like kind of scarf and lap joint sort of techniques where you sand in at an angle and then you build back out at an angle to spread load across plies, and then you'll oftentimes if you have access, you'll ply from the backside, and so you're generally quite a bit thicker in wall thickness at the point of repair, which means that area is stiffer. In a lot of cases, it's stronger than the original, but it's always stiffer than the original. And in the case of a wheel, it's also now heavier than the original. And so I would say even if you could safely repair it, you're going to add a balance problem, possibly add like a little bit of a lumpiness to the ride, because that section of the rim now has a totally different compliance stiffness than the rest of it. But also it's just, it is the thing that's 20 to 50 millimeters off the ground, and the only thing connecting you to the earth when you're riding your bicycle. So, failures there are of much, much higher consequence than failures in a frame. I mean, there's certain frame failures that are you're probably going to get hurt, but most of them are kind of no big deal. And they're more frustrating and upsetting as an owner. Is like, oh shit, now I got to spend money. But you're not so likely to get hurt with most frame failures, whereas most wheel failures are pretty likely to hurt you.
So going back to the "it depends" part of your answer, you enumerated a number of vectors, right? There's where it broke, and I don't know if you said on what kind of bike it was broken, road versus mountain. I mean, what are some of the things that you would say raise a red flag for you that, well, this is not something I would even consider having the bike repaired?
I mean, I would say certainly anything where you're like broken through a tube, particularly like a main triangle. If you have a top tube that's been severed, it probably technically is repairable. But understand the hardest part, I think, of the non-destructive testing that needs to be done is that all the NDT methods out there really come out of aerospace, and all the parts that you're doing in aerospace typically are really large and pretty thick and have fairly small curvatures, right? And so, you think of an F-20, like our NDT lab here, they do all these really cool like parts for the Raptor and the F-35. And, like a tight radius of curvature on one of those aircraft parts is going to be like, 10 centimeters, right, of radius. And it, in a bicycle part, I mean, you can have parts that are in the like millimeter range for radius, right? And so even the smallest ultrasound heads are flat. And, if you've got a call it a 10 millimeter radius in a part, and you've got a 5 millimeter diameter head that's you can't scan that very effectively, and the technology just isn't there for these tight radii. And so that's a problem, right? If you can't scan it to really understand, you think of like if you have a top tube that's been severed through, well, clearly it's broken where it's broken, but there's likely residual damage running some length of that tube, if not the whole length of that tube, right? And so it's trying to get your head around, well, where does it stop, right? Because that's going to define where you can start repairing. And so, there's a lot of damage that I think is very likely, the sort of rule of thumb that we always say is, you really need to think that there's probably 5 times or so or more damage than you see, right? So if it's a 1 centimeter damage, it's probably at least 2.5, 3 centimeters either side of that, and maybe more. So if it's a seat stay or a chain stay or something like that, you can probably repair that pretty safely. And you break a chain stay or seat stay again, it's not the end of the world, but you break a top tube descending quickly or a fork. Like I would never repair a fork, right? Because the cost of anything going wrong with your fork, doesn't matter what it is, it's really bad.
Mm-hmm. So, how catastrophic is it going to be if the repair goes wrong? Is a great, litmus test for repairability.
Yeah.
Right.
Yeah. Yeah. The other thing I'd say too is, you can't, and this really gets into like deep industry talk, but you can't see the inside of your frame. And, trust me from 25 years experience doing this, like they are far from being the same, much less even similar to each other on the inside. And so, there are frames that ship new that like an aerospace NDT lab would certify as broken while they're in the box. They're wrinkled, there's voids, there's, all of these pre-existing problems. And people aren't breaking frames and dying all the time. And so it just tells you that, we're still pretty good at building to some safety margin or in a sense, overbuilding the frames by some amount. But as soon as you start cutting into it and doing repair and trying to balance loads and stiffnesses and stresses and all that stuff, oh my God, all of those little things just come back to bite you, right? It's like the old house, you go to hang the picture frame and you can't get it hung because it's plaster and lath wall, and you drive the nail and it breaks the lath from the plaster, and now it's a total shit show.
You sound like you're speaking from experience.
It's like 100-plus-year-old house. Like hanging a picture frame can become a 2-hour ordeal that involves 3 trips to the Home Depot and more money. And you're going to end up with you're going to end up with a crappy repair compared to what you started with. And so, again, all those things I think should be taken into consideration. And then my real hope for the future, and I think we talk about this in the recycled carbon and the sealant and all that stuff that we do, but my real hope for the future is that we can ultimately get to some good production methods for thermoplastic resin composites using carbon fiber, at which point you will actually be able to recycle that broken frame into something else that has value and is functional. And that's 10 to 20 years out. But that would be my real hope.
Love it.
Yep. For now, use your crash replacement or your lifetime warranty and just get a new one. If you need to. Yeah,
or like I said, send it. I've sent numerous people to Ruckus, and there's others out there, but I think that's the other. You do get what you pay for, and part of that is honesty. Mm-hmm. Like you need to, don't take it to your buddy down the street that made a sea kayak one time and knows fiberglass. Like you're gonna die. But you need to send it to somebody who's gonna has the tools to scan it and say like it either can or it can't, and then if it can, it's gonna be X dollars, and then don't freak out when it's X dollars because it's a ton of work. I have done a lot of carbon repair in my day, and it's like most things. It's 10 times harder to repair it than it was to make it in the first place. That's absolutely for sure.
All right, let's keep the materials theme going here. And we got a question in from listener Carl Sundquist. He reached out via email. Oh, an old school on us. Email, what's that? He wrote, clearly, printed titanium and 3D printing in general is the wave of the future, and you guys, meaning Josh at SILCA, are justifiably proud of your 3D titanium products. Since alloyed titanium frames began coming out on the market almost 35 years ago, the tubing has been classified either 3/2.5 or 6/4 for its alloy composition, each with its own pros and cons. He asks, how does powdered titanium compare, and are there different alloy compositions for powdered titanium as well?
Those are good questions. Carl Sundquist, how cool. I raced against him a couple times years ago. I think he's a total badass. Carl, thanks for the question. The answer to your question is yes, there are absolutely different alloy compositions for powdered metals. All of the titanium printing we do here at SILCA, we use 6Al4V atomized titanium powder, and so it is exactly, it starts life as a ingot of 6/4 titanium, just like you would make a tube from or CNC machine into dropouts or whatever. And then they atomize it into this really tightly controlled powder that has a very fixed diameter and a very high sphericity. So it's like these little, call it 5 to 10 micron spheres of titanium. The process is actually, as you're printing, you're essentially using lasers to like weld layer upon layer. And so, you can think of it as like a ream of paper. It's 500 sheets of paper in a stack. That's kind of a similar thing, except it's 500 layers of titanium powder, and you're welding them down in place. What's cool about it, and we always kind of joke about it here. The early days of 3D printing, especially in metal, there were porosity issues, and so I think in all of our minds, mine included, I still always expect you take a printed part to the grinder and you grind on it, and you expect it to look a little bit more like Swiss cheese than metal. And of course, the technology now, we're 99.7, 99.8% density coming out of the printer. When you grind it, there is always a moment of like, damn, like that's pure titanium. It looks just like any block of titanium you've ever seen. It's really impressive. And so we also will do, with most prints, you print like a test coupon for testing of some sort, fatigue or tensile. But we also do a lot of density cubes, and those are fun because it's just they're some of the most impressive parts we print, I think, because it's a perfect cube, and you measure it and weigh it, and it's exactly titanium, which is cool. So yeah, the beauty of the 6/4 tie is that it is stronger and harder than the 3/2.5. The downside of that is it's much, much harder to work with than the 3/2.5 titanium is. But of course, in our case, the hard to work with is much less of an issue because we're printing really almost everything to size and to spec. Even like we print the threads in. We print the holes in and the chamfers and all of those details. And so you really, parts come out, they go to the heat treater. We do a super high purity vacuum solution heat treat, and that actually takes the parts essentially to perfect titanium density. It's exactly what you would do to heat treat, any billet titanium product that you made. Yeah. And am I missing I don't think I'm missing any part of his question, but yeah, so it's, at the end of the day, you think of it as 6/4 titanium. Mm-hmm. There are other alloys that people can print, but for us, this is the best, and it works in our world, and I would say in most cases, a lot of our frame builder customers, they're welding our 6/4 parts into 3/2.5 tubing, and the tubing continues to be 3/2.5, 3/2.5, whatever you want to call it, largely because it's just so much easier to make a seamless tube in that alloy. 6/4, you really have to make a sheet and then weld it into a tube. or make two halves and then weld that into something. It's just too hard to make tubing from.
If you were to make a set of cleats, Josh, one out of 6.4, one out of 3.25, would the user notice a difference?
The 3.25 would wear out much faster.
Okay.
Yeah. Yeah. The 6.4 it's both harder, but it's also tougher, and that really kind of comes into play, and you notice it. We see it with our frame builder friends as well. You take a file to it or a sandpaper to it, and it does not want to be filed or sandpapered on. Mm-hmm. and so that's where a lot of depending on the builder, a lot of the work that we do here, we have a whole army of really specialized finishing equipment, and so we typically take tubing samples from our customers, and then we can work to match that in the finishing that we do here to save them time and effort when they're actually building the frame.
All right.
You're up, Fatty.
I'm up.
Yeah.
Great. Man, I am learning so much this episode. This is so good. So I want to talk now for a second about one of the things I like about our sponsor, The Feed. And this is going to sound a little circular, guys, but stay with me for a second. What I like about The Feed is what I like about The Feed.
So you like them because you like them?
Yes, I will. I guess, yeah. But really, it's that there is so much to like about them, meaning they have a huge variety of products from nutrition to supplements to training gear with massive brand variety in each of those categories.
Yeah, and that variety would be a little bit overwhelming if they didn't also bring easily available expertise to the table. For example, if you're interested in getting the right mix of supplements for your gender and age and discipline, you could easily be confused if you had to select them on your own. But instead, you just go to thefeed.com/MG, click that Save 40% on your first order button, and choose the feed formula that experts have thoroughly and thoughtfully figured out for you.
Yep, and there is a wide variety of formulas. If you're a woman, you might want to take a quick quiz, which will direct you to the correct one of 5 formulas designed by Dr. Stacy Sims. If you're an endurance athlete, maybe you choose Pete's formula. That is the mix that Pete Stetina uses. Maybe that's why he's so fast. If you're having trouble with sleep, maybe choose the sleep formula. And that's just a few of the options that are available.
And you can, of course, design your own formula if you already know what you're after. Regardless of what formula you choose, your daily supplement mix comes in daily packages, so you know what to take and when. And it's easy to take just the pouches you need along with you when you're traveling for work or an event.
Yep, so it is worth noting again that you will save 40% off your first order by going to thefeed.com/MG. And thanks again to our friends and athletes at The Feed for sponsoring the show. So here is a fun question for you, Josh, that came over the Marginal Gains hotline. This came by text. Of course, that's a great way along with voicemail. You can ask Josh practically anything. We're proving that this episode. 317-343-4506. Sean B. from Phoenix asks, Josh, my friend, is going to attempt to set the Guinness Book of World Record for the 10K pushing a triple stroller. I believe that means a 3-across stroller. Let's marginal gain this. I am thinking a 1-2-3 pyramid of runners in front of her. What could we do to a stroller, such as wheel bearings or fairing covering or anything like that, to help her get that world record?
Wow.
There's an easy one. There's low-hanging fruit there, first of all.
Yeah.
The 3 across is wrong. You want to go front to back with your 3.
3 front to, yeah. So funny story. I know those exist for the reason that after my wife had our first child, she worked so hard to stay in shape, and she's probably, 6 weeks, postpartum, and she's kind of running again. And we went for a jog together on this local trail, and she's like, "Yeah, I'm feeling pretty good, And I kid you not, this woman pushing a triple stroller with like probably 4-month-old triplets in it ripped past us, kicking our ass. We're like, oh shit! Like, look at her. She's like, I don't feel as good about myself anymore. You're amazing. But so I know the front to back exists. Probably a little hard to turn, like a modern F1 car, because it's so long.
That's right.
We'll get that dig in there. Yeah, I would say go with the front to back configuration if that's possible and allowed by the rules. I would 1,000% use a fairing if you can, and if you can't use a fairing, I would pick maybe a day that was a little overcast or drizzly and see if you could use one of those like clear plastic rain covers pulled nice and taut over it. And, it's a little bit like the rider's like, ooh, it's a little chilly today. I think I need shoe covers. When we argue with the UCI, they're going, it's 72 and sunny. Oh no, I see in the radar, it looks like some rain might be coming. That could be an option. I would think, wheel cover. I mean, they're tiny little wheels spinning quickly, so tire pressure is going to be potentially meaningful. I don't even know what would be on there, but if you could get a slightly bigger wheel with a slightly higher quality tire, that is going to make a really big difference. I mean, some of those, stroller wheels, the smaller they get, the inefficiencies just go crazy, right? Especially on rougher surfaces. So, I'd get the biggest wheels you can get in there, get them in there. Bearings, that kind of a similar thing. You're not going to pick up huge gains there, but there's absolutely gains to be had. I would think at a minimum, I'd probably flush the grease out and oil them. It's only 10K. It's not that far, and no seals, no grease. That's going to get you half or 2/3 of the way to like a ceramic bearing upgrade sort of performance. Although it's hard to say, a lot of these strollers probably come with some pretty crap bearings, so maybe the gains would be bigger than that. The other thing I would think of there, just from the runner's perspective, would be playing with, and I am not like a running biomechanics person, but from my own stroller pushing experience, I would be really careful to play with the height of the push bar relative to the runner, because you think like it's too low, you end up kind of pushing down, and now you're just adding normal force into your tires, which is going to push rolling resistance up. But it's also biomechanically, it's bad for your running. I would, in my mind, I think your ideal would want to be to get that push bar up to like kind of exactly your hand height of your arm swing, so that the pushing you're doing is as horizontal to ground plane as possible. Mm-hmm. So yeah, I would say all the above are going to help. I'm assuming there's children involved in this.
I was going to say, you want to do this as soon as possible, right? If you wait until your kids are 6 years old, it's going to be a problem. I mean, if for no other reason than the complaining, Dad, Mom, are we there yet?
How about a pair of Nike Zoom X Vaporflies? Don't we want to run that?
Yeah,
you can't. Right. Yeah.
You can't go wrong there.
And make sure you're wearing a top that's not flapping in the wind. Josh and I and Fatty have railed on that with runners before.
Yep.
Have the kids wear aero helmets.
Oh, aero helmet would be huge. Mm-hmm. Also, I mean, I think, for women, get, the hair pulled back.
Right.
Kind of the tight bun or the ponytail where you kind of like have the multiple scrunchy things down the ponytail to keep the hair behind the head so that it's not flapping about the side. But the other one that we know is big is, like the hats or visors, are problematic, right? So, so if you're going to wear a hat or a visor, wear it backwards, or don't wear one at all. Who was it? Somebody just launched Aero sunglasses. I haven't. It's POC.
POC.
It's POC because have one of the teams is sending a set that they wanted some testing done on it.
I thought it was a helmet sunglass combination. Like they'd somehow put the two together to make a kind of a package, almost like they did with TT helmets.
I am honestly I'm not deep enough in the details. But if sunglasses were ever to matter for aero, it would be when running, right? When your head is straight up. Mm-hmm. I think as we've seen with cycling, I mean, the downward angle of your face, what's aero in like a face shield. I mean, I see this all the time with time trial helmets. The aero face shields just don't work for some people because their head angle's too shallow. They're facing too much towards the ground, and you're out now just directing airflow down into your belly rather than around the head. Whereas when you're running, I mean, it's something that directs airflow one side or the other could be huge. And then the last thing I'd say there that I hate to say this because I hate everything about it, but we in COVID with the one of like 2 or 3 wind tunnel tests I did during the whole like 2 years of COVID, for shits and giggles we played with a couple of masks, and we found that like the some of those like N95 like pointy whatever, I mean some of those could be like 10 watts of savings. Really? And I totally hate everything about that, but yeah, but it makes sense. Your face is not a very
not good.
aero object, and I mean, and maybe for some people, but if you can put a thing in front of your face that's more aero than your face, that's a win.
Just make sure you can breathe, because the N95 is going to there's a little problem with oxygen intake with that thing.
Yeah.
And the fewer turns you have to do with something that long and awkward is going to make a difference. And
point to point, get a point
road
to point
surface.
course.
Yeah, if you can do a straight 10K, if you don't have to run it around the field, whatever the rules are, that's going to make a difference as well. Sean, let us know how it goes.
Very, and tape it, videotape it, or something. That sounds.
I would love to see. I would love to see that.
All right, we got more. Another aero question here. Go ahead. Sorry, Josh.
Oh, I was going to say, I want to know, too, like how, like, at what level is this attempt? Like, are you rocking up at the local 10K and trying to set the record, or are we going to, like, that New Mexico time trial course, that gains 1 meter over 20K or whatever, and doing it straight line? Because, I mean, I would think you could pick, like, that course and run it straight line, no elevation with the tailwind. Because I know in running, right, you've got to have... I can't remember, it's like a couple meters per second before it is allowed before they'll say you can't have a record.
Weather matters.
So if you timed all that just right course, right day, high enough but not too high tailwind, that could all be super exciting. So anyway, let us know. I want to see pictures.
Okay, more aerodynamic stuff, and this came via text. 317-343-4506 is the number you can use, and that text came from Zach. He's a sailor, a cyclist, and a computational fluid dynamics scientist.
He's our people.
Makes me think maybe he should just be able to answer this question on his own, but he really wanted to hear from Josh on this. He says he's getting a new gravel bike, and he wonders, could there be an aero and weight advantage to running a one-by setup? He said he started doing the math on his preferred gearing and realized that he could run a large aero chainring, 48 or 50 tooth, on the front without fear of spinning out and still have access to his preferred lowest climbing gear ratio of 1-to-1. He asked, might the aero benefits of an aero chainring and no front derailleur be advantageous, I should say, or would the mountain bike rear derailleur and massive bailout and cassette ruin any aerodynamic advantage? One by aero advantage.
I think the simple answer, other than it depends, is yes to all of it, pretty much. I mean, he's spot on in the rationale. Yes, the one by aero chainring is absolutely slightly watt or two, maybe a few more. more aero than a double chainring with front derailleur. But yes, also to large cassettes are less aero than smaller ones, and in particular, the longer cage derailleurs to handle those are again less aero than their counterparts. So the testing we've done with and around this, really shows it to generally be a wash. And my opinion, kind of overlaid on top of that, is that the aero tends to be a wash, but the friction, as we've talked about before, the friction effects of the 1x and the 10-tooth cog and all of that other stuff tends to always be to the negative. Mm-hmm. And so, I love 1x for simplicity, for maintenance, for ease of building the bike, for all that stuff. But if I were, putting a bike together for a pure performance over mixed and varied terrain, and I think particularly if you have terrain that's necessitating that 1-to-1 gear ratio, I think the 2x is almost always going to end up in your favor just purely on a friction side of the coin. Because the other thing that comes into play, other than my longstanding hatred of that effing 10-tooth cog, but other than that is the cross chaining and the ability to run large ring with small cogs and small ring with larger cogs. We've seen extreme cross chaining. It's watts of loss. That's really unnecessary, and so all of those things combined certainly push me, in my own setup. And I'm trying to think, I don't know if there's an athlete we've ever worked with on like a FKT or one of those things or a race prep. I honestly can't think of anybody we've ever pushed toward 1x. I don't think it's ever happened. But I, at the same time, I would say
that's a good answer.
I would say at the same time, if it's a long flat, if the Unbound 200 were flat, right, and for those who've never been, it's Kansas, but it is not flat. Mm-hmm. But if it were much flatter, there probably would be a good argument for a 1x with like a short cage rear derailleur and a relatively manageable rear cassette with a nice aero front chainring. I mean, there will be watts of aero savings there, provided you don't need that huge range in gearing that's going to cause you to have to make those other decisions to give all that stuff up.
I have a pretty good understanding what's on the market. I just don't know. I mean, I think on a gravel bike he would want, a narrow wide front chain ring, and I don't know if you can get one in a 50. I mean, that's a big one. And then again, speaking of narrow wide, he's going to introduce more friction with the narrow wide. Am I right on that, Professor?
Yeah. They're all generally higher friction. So, yeah, I guess the other side of this, and full disclosure, we just did a big gravel wind tunnel test yesterday, so I've got gravel wind tunnel front of brain. For those of us who aren't front of pack at these things, I mean the numbers, the aero differences aren't that big. Yeah. And it's especially because it's so tire dominated in the flow. I mean, we actually had a ton of fun, and we'll be posting a bunch of on Travis's show that he does with us, the Road to Emporia. He's going to be posting, and then the athlete we were in the tunnel with was Dylan Johnson, and so he's going to be posting and doing some video content around it. But it was really fun and fascinating that sort of thinking in aero terms of like zones of the bike. Once the tires get above 35 millimeters and they've got some knobs on them, I mean, it's kind of like almost everything on the bike down there is just muck. and at the tire width you really need, that 45 or so, it's even more so. And so I think there's things like If you've got a gravel bike with 40, 45 millimeter tires on it, we didn't test this yesterday, but I'll tell you things like adding or removing a down tube bottle were like essentially unseeable. I mean, like in the noise of the tunnel, the thing that, and we were working with one of the really beautiful new Factor Aero gravel bikes. And so you're like, okay, if putting a giant cylinder in front of your aero down tube has almost no negative effect, then, not a whole lot else that's happening down in that wheel zone is going to have a ton of effect. Whereas the frictional stuff is always there and real. So, I would certainly prioritize friction over aero for gravel for all but the pointiest end of the field. Mm-hmm. We're talking, at the 22 to 24 mile an hour range, it's watts of savings potential. At the 16, 17 mile an hour range that most of us are doing, it's fractions of a watt.
Any porpoising problems with a gravel bike? No,
not on this trip. Not on this trip. But, I'm sure if we, with the right tire pressure, we could probably set something up.
Yeah.
See, I was going to say, I was so excited that this is the closest I think we have ever come to an answer that is not. It depends. That was a good, solid get a double. Is what I am marking that down as. That is only 5 questions that we have answered, semi-answered in this last hour. But we've got dozens more. Honestly, we should do an AJA marathon, a 15-hour, no questions barred podcast. I think we could clear the queue.
You going to edit that?
It depends.
Yeah.
It depends. Yeah.
But just because we've still got a lot of questions in the queue doesn't mean we don't want to hear your new ones. And here's how to get your questions to the top of the pile. You got to get them past Fatty and I, but that's another topic. Text or call the Marginal Gains hotline, 317-343-4506. Again, 317-343-4506. You can also leave a comment on this or any episode at marginalgainspodcast.cc, which is where you'll see links to all platforms for listening to this show.
And we'll be back soon with more questions that you desperately need answers to, if only you'd thought to ask them. And we're able to get them not past Hottie and Fatty, but actually in front of Hottie and Fatty, I think is how that actually works. So, but thanks for listening to us on Marginal Gains.
Woohoo!